right, boys and girls, now that you have had a chance to work on this with your partners, we are going to go over it together as a class. Okay? So Brenda, she's passing a magnet through a mixture of iron fillings and sand. What properties of the mixture does she demonstrate? So what are these properties that is happening when she's using the magnet going through the iron fillings? We know that Brenda is showing that iron keeps its magnetic property in a mixture. We know that nothing happens to iron. And the sand does not gain the ability to be attracted to a magnet. So iron keeps that magnetic property, and the sand does not gain the ability to all of a sudden, oh, I'm going to be magnetic. Okay? We look at number 2, and we're talking about we have this warm sand and cold water. And so again, what are those properties of sand? Or what are those properties of water that are going to remain the same? They're not going to change. And if we look at that, we see that the mass, that weight of the sand stays the same. Okay? We also know that that weight, the amount of water, that stays the same. And we know that the state of matter, so basically that the water is a liquid, the water stays liquid. So that also does not change. We have done this one multiple times, where we have talked about iron fillings and when they're mixed with sand, why do those properties remain the same? Well, because once you're magnetic, you're not going to lose your magnetism when I mix it with something. I'm still going to be magnetic. So my iron fillings, those properties are going to remain the same. The fact that it is a solid remains the same because I'm putting it in a mixture. And remember, when we create mixtures, our properties stay the same. Okay? They're not changing. Those iron fillings are not changing into something new. They're still iron fillings. So all of those properties that iron fillings have without the sand, iron fillings are still going to have in the sand. Because again, it is a mixture. None of those properties changed. And we can easily describe that within 2 to 3 sentences here. When we look at the next question, we're looking at number 4, and we have this table, and this table is showing physical properties of sand, water, and the 2 samples are going to be mixed together. Okay? So we have the mass, so how much do they weigh? The volume, how much space it takes up. Is it magnetic? And then the color. And so I want to see what statement best explains the properties of sand and water after I mix them together. Okay? Well, here's the thing. If I put sand and water together and they mix up, I am not forming a new substance. Nothing new happens. So that's a ridiculous answer. Sand and water remain the same substances. They keep many of those properties when I mix them together. Again, this is a mixture. I'm mixing them together. They do remain the same. That is my answer. Because again, they're not increasing in mass and they're not becoming new substances. They're remaining the same substance. And they keep many of those properties when they mix together. Our next question is liquid water and salt will combine to form a solution. How do their properties compare before they are combined? Okay, so before I mix water and salt, my water is a liquid. Okay, my water is a liquid. I also know that my salt is a solid, always. So before I put them together, my water is this liquid, my salt is a solid. And so now after the solution is made, the only thing that changes, my friends, is this appearance. Okay, the appearance of the salt is going to change. My salt is still salty, so my taste, it doesn't change. I still have the same amount of it. It's just the appearance because now it's dissolving into my water. Looking at question 6, we're talking about Velma and how she's investigating this powdery solid, okay? And it forms a solution with water. What changes will she observe to the powder and water as they mix together? So what changes are going to happen as the powder and water mix together? We're going to select every correct answer. Okay? The powder grains keep the same size and shape as they spread throughout water. No. I'm not keeping the same size and shape as I'm spreading, because what we do know is that the powder grains are going to gradually dissolve. So they start to break apart, they gradually dissolve, and it's almost like we don't see them. Okay? I also know, remember when you were stirring, we put food dye in, or when you were stirring with the colored stick, what happened? The water takes on that color, right? And then I also know that the water is going to take on the same colors everywhere it goes, in all of its regions, everywhere. That water is going to gradually take on the color, okay? So eventually, if I'm putting a pink powder in it, my water eventually is going to completely be, all throughout my water, the whole cup is going to be pink, okay? All of the water in it. My powder grains are not going to melt. They're not going to change from a solid to a liquid, so that's kind of a silly, silly answer. So the 3 things that happen is my powder grains are gradually dissolving, almost as though they disappear. The water is gradually taking on this color of the powder, and then the water is also gradually taking on this color all over. So not just part of the water will be pink, but all of the water will be pink. So Jordan, he mixed a small packet of sugar into his lemonade. Okay. Now I'm forming this solution. How does it change the sugar? By my sugar going into to my liquid lemonade. How is that changing my sugar? Well, the appearance of my sugar, it changes, right? However, my taste stays the same. It's still sweet, and some of my other properties remain the same. Okay? So the appearance changes. It's dissolving. I might not be able to see it as clearly because it's seemingly like it almost disappeared in my lemonade. However, I taste it, and it's still, some of the other properties are still there. Here's another one of those SCRs. Oscar, he's making this solution. Okay. And he has 30 grams of salt, and he's putting it into 1,200 grams of water. So he's pouring a little bit of salt into water. And he wants to show that matter is conserved in the solution. Matter is saved in this solution. So we want to think about the properties of matter that we still know are there. Okay? And that goes back to a lot of our earlier questions when we talked about it. Okay? If I'm putting salt and I'm stirring it in, one of the properties on my matter that's still there is the taste. It's going to be salty. That doesn't change, right? And also, even though it's starting to dissolve, the amount, that 30 grams, that doesn't change. So my mass also doesn't change. So we can show that the taste doesn't change. We can also show that the mass, the amount, that 30 grams is still 30 grams of salt, no matter what I do with it, even if it's dissolving into that water. Nine, we have this picture of the balloons, okay? And we have an inflated clear balloon, and it has a greater mass than the same balloon before it's inflated, all right? I want to know, what does that show us about the particles that make up air? What does that show us, okay? It shows us that the air is made up of particles that are too small to be seen. We can't see those particles. And a balloon, therefore, is completely filled with those particles of air. As I blow into that balloon, it is completely filled with all the particles of air. But I can't see them because they are way too small. Just like when we talked about the atoms and how everything is made of atoms, and we can't see them because why? They're too small. We can't see them. Everything's made of matter. Can't see it because it's so small for us to see. Okay? The last question, very last question, is here is air in a balloon, and you can see those particles, right? And I want to, why do I want to look at this picture? How does this picture help us? And the thing is again, it's showing us that the balloon is filled with these particles that are too small to see. I can't even see them. They're there, they're in the balloon, they're too small, we can't see them. All right, boys and girls, I know that a lot of this we haven't had the opportunity to fully go through at least a couple of these questions. Most of them you should have known near the end. There is a couple that we haven't gone through, but we're still working through it. We're still going to be learning a whole lot more about the particles and about more properties. And tomorrow we're going to do some experiments that explain these in a more feasible way for you guys to see and understand. And I can't wait to see you guys tomorrow.